You know, when most people swallow a pill prescribed to them by the doctor, I think we can agree they don't really think about the fact that the drug will not only do something to the body, but also that the body will do something to the drug. They are two different kinds of interactions between a drug and the body. This lesson will explain the former, what a drug does to the body, even though it's only half the story. Let's define pharmacodynamics. Pharmacodynamics is, in short, what a drug does to the body. More technically, it refers to the study of how a certain concentration of a drug produces a biological effect by interacting with specific targets at its site of action. The first definition I gave you is very simple, but not specific. And the specific definition is not very intuitive. So let's figure out what pharmacodynamics is by expanding on the definition a bit more. A drug exerts its biological effects by interacting with the receptors located on tissues and organs throughout the body. The effect of the drug is thus dependent upon the drug binding to the receptor. If we increase the concentration of a drug at the place where a bunch of receptors are located, we can thus conclude that the intensity of the drug's effect will be larger with a greater concentration of the drug. This isn't always true by any means, as other factors can influence the intensity of a drug's effects, but that's the basic gist of it. Regardless, let me give you a real-world example of pharmacodynamics you can relate to. If you mix 1 teaspoon of salt in a cup of water, it'll taste slightly salty. That salt is like a drug interacting with sensory taste receptors on your tongue. If we dump a cup of salt into a cup of water, we increase the concentration of the salt. Now try drinking it. It's going to be one intense experience because we've increased the concentration of the salt, but the number of sensory receptors has stayed the same. This is what pharmacodynamics is about. It studies the relationship between a drug's concentration at its site of action and the resulting intensity of its therapeutic or toxic effects. All of that being said, there are two very general effects a drug may have on the body. A drug may be an agonist or an antagonist. Agonists are drugs that bind to a cell's receptor in order to mimic the effects of a substance the body naturally produces that binds to the same receptor. Think of a lock and key example here. You may have an original key that inserts into a lock and produces an action, the unlocking of the door. You can also go and get a similar key produced that mimics this original key, one that will produce the same effects as the original key. That's an agonist. On the flip side, antagonists are drugs that bind their receptor but don't actually activate it. This would be like a key that fits the lock but doesn't do anything. It doesn't unlock the door. All in all, what I want you to grasp is that when we give a person a drug, we either generally expect it to mimic the actions of substances the body produces naturally, or we expect it to block the actions of natural or synthetic substances trying to bind the same receptor. Pharmacodynamics very simply describes what a drug does to the body. More technically, it is the study of how a certain concentration of a drug produces a biological effect by interacting with specific targets at its site of action. Two very general things a drug can do to the body is agonize or antagonize its receptors. Agonists are drugs that bind to a cell's receptor in order to mimic the effects of a substance the body naturally produces that binds to the same receptor, while antagonists are drugs that bind their receptor but don't actually activate it.